I'm Jim Lake. I'm Vice President of Training and Technical Services here at Viking, and today is an interesting Tech Talks and something brand new format here. This is not just me and Sean talking in this one. I got some pretty heavy hitters here. We're going to talk about antifreeze, the history of antifreeze and where antifreeze is going. I've got Scott Franson, James Golinveaux, and Martin Workman here. We're going to talk a little bit about the history, a little bit about Viking's history with this topic. I brought these guys along because these guys were with me actually in 2010. They were in various parts of the industry in 2010 when the antifreeze topic actually kind of really took off and changed significantly from its previous 70 years. So one of the things I wanted to chat with you guys about is, we're going to just take a quick walk through history here, because it was 1940 when NFPA 13 first brought on the concept of using antifreeze in water-based sprinkler systems, and it was in the appendix, and it was really just something that they said, be very careful when you're using it. They referred to minor unheated areas, not very enforceable, but minor unheated areas. And they actually called out things like carbon tetrachloride mixed with oil as one possible option, as well as Prestone. They actually called out the product, and we don't do that pretty much anymore.
I believe they titled it non-freezing solutions.
Right. It started off as non-freezing. That's right. So So we, in the next edition, or in 1953, it moved into the body of the standard, but it really didn't have much more solid language. Propylene glycol was added, and then there was some discussion about the concentrations, how strong it could be to protect against freezing. And actually, those concentrations continued all the way up until the 2010 edition. So it wasn't until the 50s that they started to say to limit the size. And I know, James, you had some thoughts on where that came from or where it was going and some ways that it had changed. Because it started at 20 sprinklers, then it went to 40 sprinklers.
Right.
Then it went to 40 gallons.
There's a history to the change. You know, it came around in the 1940 edition that it said non-freezing solutions. Then in 1953, it did move to the body under Section 5511. It wasn't a 5-something. It was 5511 back in 1953. And that's kind of an important note, because that's the first time it was regulated in the standard, in the body of the standard. In 1972, 5511 was modified to put 20 sprinklers as the maximum recommendation. It didn't say, it just said you should not.
Yeah, the language wasn't still very strong, not like we have now in the body of the standard.
Right. So it just said you shouldn't exceed 20 sprinklers because of cost, which was very interesting. It wasn't because of fire protection. It was, it's costly to replace, it's costly to maintain back then. So that was a recommendation from NFPA, which I find very curious, because NFPA doesn't really get involved with cost. It's either okay or not okay. So we tend to stay away from that now. In 1973, it moved to the annex, again with the 20 sprinkler limitation, and again, just a recommendation not to exceed 20 sprinklers. Interesting, in 1983, they were doing in the 1973 from the annex, it turned into the 1974 edition. So it started in 1973, and that's when NFPA would publish the ROPs and the ROCs back then. It would always be the year before the standard. So it showed up in the 1974. In 1983, there was a proposal from someone to say, let's change it to 60 gallons instead of 20 sprinklers. So the proposal was, let's make a 60-gallon limitation. The committee debated that, looked at the costing that was proposed as the substantiation. It wasn't fire protection, it was costing. And the committee decided to go to 40 gallons in the technical committee report. When the standard got published in 1985, it said, in 1983, it said 40 sprinklers.
Right.
So they made a technical error. Instead of saying 40 gallons, they went to 40 sprinklers. So for one edition, it remained as 40 sprinklers, and then in 1985,
Got correct.
again in an ROP, they changed it to 40 gallons. And the reason I walk you through that history is people believe that the 40 gallons was a fire protection rule.
Yeah.
It was an economic rule. 20 sprinklers was an economic rule. It really, there is no magic bullet that says 40 gallons and above is something worse than 30 gallons and below in any particular system, especially when you have a concentrated fluid around a fire event. And it's unfortunate, but we kind of use that as our baseline now for new listings moving forward. Everyone thinks that 40 gallons is a get-out-of-jail-free card. And it really isn't a fire protection issue at 40 gallons. It was an economic issue that we just have in legacy.
It's economy to scale over a dry system, and that was the key to it.
Yep.
When you started weighing that out, anything less than that, you couldn't, it seemed ridiculous to put in a dry system for 15 heads.
Yeah.
Because your smallest dry valve at the time was 3-inch. They were quite, I mean, you're talking about really adding some cost, so when you really do back it down to the justification was cost, yeah, it makes sense. How do we put sprinklers in and, you know, not charge an arm and a leg?
So the first time, and the first time 40 gallons ever appeared was 1985. Most people think, oh, it goes back to 1920 or it goes back to 1940 when we were using antifreeze.
Right.
Well, 40 was the first time we recognized it, but it wasn't until 85 that we said 40 gallons for economics, and that was, again, in the annex.
In the appendix, yeah.
And so the conventional, up to that point, and then a couple other changes, calcium chloride was removed because it was pretty much a bad actor in sprinkler systems anyway. It tended to clog things up. But one of the things that was really important at that particular time, and it was the fact that a lot of the discussion and the conventional wisdom and everything was we were focusing on its ability to protect against freezing. And it wasn't really until all the way back into the 1940 edition, there was some recommendation saying, be careful with this, make sure you dilute it down into something that's not combustible, but it was just kind of, again, general language. And it wasn't really until the 2002 edition, leading up to that, and then into the 2007 edition, which was 2006 cycle, that we started seeing even more discussion about, hey, this stuff's combustible, maybe we ought to say something about that. And then, Martin, you had a proposal in the 2000. Viking was very active in the 2007. There was a bunch of you guys. There was you and Eldon Jackson and Don Dornbus all submitting a whole bunch of stuff on basically ESFR. But you made a proposal that was subsequently rejected by the committee that got into this discussion of, hey, factory premix is the way to go with this, or a solution versus a mixture.
Correct. Right.
And that was a neat, that was kind of interesting to see because it's the first time that kind of came up. The committee said, no, there's no proof of anything. So I mean, you were a contractor before this, so what was the?
Yeah, there was no control or actually any direction on how you were going to mix call it antifreeze, out in the field. So if you got a 5-gallon bucket of whatever, glycerin, propylene glycol, those were the two, you would take a larger bucket usually and pour water and mix it with something, whatever you had.
Whatever
it could be a shovel.
Canoe
could be a
paddle.
Canoe paddle,
Yeah.
I always say a canoe paddle or 2x4. And then when you thought it was mixed, then typically you take your test pump and pump it into it.
Right.
But so I always loved the little fill cup on an antifreeze. It was like, who would ever do that? Can you imagine getting 30 feet in the air with I don't know, I guess a
trying to put it in
pitcher?
there.
or
Well,
something?
some of our early involvement too, though, for Viking was as a result of testing done by Tyco with what was it, the
Wolflow.
Potassium lactate,
potassium lactate,
Yeah.
and then the FM testing that was suggesting
propylene
that
glycol was bad.
was bad, was flammable. And so Viking, we were disputing that. We ran residential fires in our burn building in Hastings with propylene glycol at various concentrations using listed sprinklers at listed flows. Never had a problem. We ran all kinds of fire tests, and every test we ran under those conditions was successful.
Yeah.
But
In fact,
remember, controlled solution was kind of the key to it.
yeah,
Right.
it was controlled, but it was interesting because later on you know, in 2010, 2012,
Right.
it became real obvious that
Yeah.
higher pressures,
Mhm.
see, we were only testing at the listed flows, which is 7, 10 PSI, 12 PSI.
Right.
No problem, but then you take those same antifreeze concentrations through those small orifices, and now you go to 50 or 60 or 80 PSI,
Mhm.
and it's a whole different world.
And
you
that's,
know?
and that's where the other part of that was where the premix actually comes from, that's in the standard, well, it was in the standard when all of the TIAs were flying. But there's an important point to make here in that these two solutions, or these two chemicals, are miscible in water. But to Martin's point, you have to generate enough energy to make them, and miscible means they won't separate in solution.
But there's a part of the history that a lot of people miss. So if you're doing inspections and you're testing people's antifreeze and it's not quite up to snuff, what should you do?
I know what they did.
Yeah,
Yeah.
everybody, we all,
Just,
anybody in
pour-
contracting did that.
Poured it in.
They,
Well,
they pumped in pure antifreeze.
There wasn't direction otherwise.
Mhm.
It was at this freezing temperature, pump it back in.
Right.
And here, where we live, it would be abnormal every other year to probably need to enrich it or change it out, or whatever you
Okay.
want to call it. So, yeah, there were a lot of systems that literally were running pure glycerin just because there wasn't any water left in it.
Right.
So the idea behind a solution is you can't add to a solution.
Right.
The whole comment
Well,
was,
and
it
the-
comes
yeah,
in this
the-
way, it stays that
The
way.
irony
stays that
is
way.
that the freezing point doesn't get any better.
Well, as you get into stronger solutions, huh? Yeah,
Right.
it doesn't, all of a sudden you
In
lose
fact,
even the
it actually
freeze
comes down.
protection.
Right,
Right.
right.
You lose the
When
freeze
the percentage
protection.
goes up, it typically, you just keep adding a little bit and a little bit. It's
Yeah,
like
you're
adding garlic.
you're
Yeah.
defeating the freeze protection too. as
And
you're
and
doing
you're
it.
adding to the flammability
Right,
factor.
right, so it's a double-edged sword on that one, so.
But
so-
the premixing argument is a very valid
It's
argument.
an excellent
And,
argument.
Mhm.
you know, the appropriate way to change a concentrate on an existing system is to drain the entire system
Right.
into a container,
Mhm.
get it
Right,
mixed on the stuff that's not premixed. Now it's changed in standard. You have to use premix
Right.
to go back in if you're not at the right concentrate. So it's not an argument any longer because
Right.
the NFPA 25 standard now says you have to use premix for refilling
Right.
the system.
Right.
So you're sort of at a loss,
Yeah.
other than the new listed fluids.
so one of the reasons I brought that as Martin is a man before his time with that proposal, saying,
Yeah.
saying, hey, guys, this isn't gonna work. But going back to the 2002 edition and in there too, that's when the 40 gallons came out. So the 40 gallons comes in the mid-'80s, and it goes all together in the 2002 edition. So I know I got some guys here that know why, so that we're gonna explore that in a minute. But that became one of the contributing factors in the incidents that led to the changes in 2010, because these systems were no longer just small, minor systems that, like the standard refers to, where water, by definition, antifreeze comes out followed immediately by water. These were much bigger, or allowed much larger systems.
Well, the system size was never regulated in 13, it was in the appendix, so it never really carried any weight anyway. I mean, you were in contracting, you'd see a lot of big antifreeze systems. One of the keys that we had is we were doing testing in 2003, where Tyco had will flow. Viking obviously, kind of disputed it, saying, what's so bad with propylene glycol? Well, our first fire test with K14s kind of showed us that, well, maybe we need to do something a little better. We moved to K25s and had successful tests with a Class 2 commodity. And, back in the early 2000s, Class 2 covered a lot. Well, now it doesn't hardly cover anything. Now it won't even cover the gloves in my car. But,
And we even repeated those large-scale fires
They
at
were
higher pressures and
repeated
passed
tests?
again.
Yeah, but one of the keys that we had for system size was we didn't allow grids. It had to be trees. It was a straight feed to the system, and we had 1,100 gallons because it was a time, because we ran it all with pure solution. We didn't have a water backup, so to speak. So what we did was we flowed 1,100 gallons, I believe in total for that fire. It was a class 2.
Before, yeah, before it was water only.
Yeah,
Right.
and so that's why that system limitation from our standpoint is if it was fire tested, and it was the argument in the committee. You know, if you had a fire test and proved it, and it was listed,
Which we did.
which
And
we did,
yeah.
Right.
then the limitation didn't mean as much, and it wasn't enforceable anyway in the appendix. It was a suggestion.
Right.
Suggestion going back to cost.
Right.
I mean, it was always a practical limit.
Okay, so now we've got, so now we have no limitations at all, but even the 40 was gone from,
Yeah, you had.
from the standard.
You had the FM approval on
Right.
the potassium lactate or the will flow fluid from Tyco, and that had no limitations on
Right.
size, based on their fire testing. You had the Viking, ESFR testing that showed it could handle, I did not know at the time the K-14, that would have been an interesting.
Well, we didn't want to show a lot of people.
Yeah, we did that at UL and then, you know, it wasn't.
Well, it goes to the droplet size again.
Right.
It goes
Right.
to the K-14 trying to discharge
And-
the amount of
Discharge.
water.
Well, it actually showed RDD because, you know, we were flowing 100 gallons per minute, and at 50% water, you only were getting 50 gallons, you
Yeah,
needed 80.
that's what it
Yeah.
was. It
So
wasn't
when we went to the
necessarily,
K-25, it was one of those things, it was one of the weirdest,
it was, you
oh
know,
my goodness, you do need 80 gallons per minute, you know?
yeah, yeah, so we're flowing 100 gallons a minute, but it was as if we were flowing 50 gallons a minute. Because we did a 50 gallon a minute test of water only after that,
Right.
and the results were identical. 50 gallons a minute water had identical results of 100 gallons, 50-50 mixture.
Mhm.
Yeah.
Yeah, it was the dumb math, it wasn't
Yeah.
about,
That's
you
why
know,
we disputed for a while there. We were disputing that was, you know, adding fuel to the fire because
Yeah.
it didn't,
It
you know,
acts as a void.
50 gallons water only had identical results as
Yeah.
100 gallons 50-50 mixture, you know what I mean?
So let me-
It was really incredible. I mean, they were unacceptable, but it was the same, you know?
Yeah. So we're talking about big systems right at the moment. Let's pivot a minute for residential, actually, because this is where, this is where
Well, that's
everything
where it
really
got
turned
bad,
on its head, yeah. 13D and 13R also had antifreeze language in them, basically saying if you've got basically assuming, I think the assumption was that if you had spaces that were, in fact, the language is there, that if you have spaces that are subject to freezing, that are under 40 degrees, one of the options was to add antifreeze to them. But it was still kind of limited to those the intention, I think, of the standard. Now, this is moving into the 2010 edition. This was the edition that I was the staff liaison for. That you're moving into this, and it's still, I think, the assumption that these are two different spaces in the building, that you're really going to be just using these where you're subject to freezing. You're not going to be chalking the whole multiple story, multiple residence building system with antifreeze. I think that was the assumption. It certainly seemed to be where the language was going.
But just from a cost standpoint, if you can run a wet system, you're going to run the wet system.
Right.
If you have floor control and zone control.
Mhm.
You know, back in 2010, we didn't have the two-story riser control, you know, the floor control rules. So you did have some bird cages, you did have some designs where the entire building would go up to the attic and come back down
Right.
again in different
Right.
flow patterns. Today, it's a little bit different because it's usually just the top floor that needs some sort of freeze protection,
Right.
if any.
Yeah. So we advance into that. We've got antifreeze now going into lots of different buildings everywhere and being installed throughout the building, regardless of whether or not it was subject to freezing, the space was subject to freezing or not. So I'll tell you right now, in the fall of 2009, I was at the AFSA meeting in San Diego, I think it was, and Steve Hart, some of you guys might know Steve Hart from California, comes up to me and says, and now I'm staff liaison for NFPA, and he says, I got to show you something. We got a problem. And I said, okay. So anybody that knows Steve knows he usually has notebooks. He had these 3-ring binders, and he just plopped it down on the table, and he started flipping through. He's going, this was the sprinkler system. And it was in Truckee, California, where an individual had died as a result of an activation of a residential sprinkler in the residential area, in a kitchen, in reaction to a grease fire, flash fire grease. The whole thing was just one mistake after another. But and I said, oh boy, we've got a problem. So I went back to Quincy and ran it up the flagpole. And boy, there's no tougher discussion you had than having to talk to Maureen Brodoff, who was legal counsel at the time, and having to explain to her what exactly was that went on. But that's where it started. That's where this whole thing started. Because the conventional wisdom was all of these things. Yes, we can. It may be combustible, but not in all cases. Pressure is an issue. Droplet size is an issue. But boy, when you looked at the details around the Truckee system, it was high pressure, very small orifice, which atomizes your spray pattern, your droplets a little bit, not just a little bit, and a lot, and you wound up with what was, I'm not sure I can't remember what they used, the term they used in the research, but it was just it was all very close to an explosion, but they wouldn't really call it that. It was,
Conflagration. or
Exactly.
something like that.
Conflagrate.
yeah.
Yeah.
But the conventional wisdom was, okay, that
Essentially,
was it.
it was like taking when you're a kid and you want
Yeah.
to burn flies, right? You take a aerosol can with a lighter, and
Yep.
that's what it
And
was.
that's what it was. So we
That's
went into
exactly
the,
what it was.
so
Seriously.
So we go forward and the
This isn't
correlating
going on the
committee.
Disney Channel, right?
That's before there was,
Yes.
you know,
This just became
That's-
PG-13.
I know, don't try this at home, kids. So it was the correlating committee at the time, because 13 had just finished its cycle. And 2010 was out there. I was giving a presentation on the 2010 standards, so there was nothing going on here. It was all closing out.
So it's funny, Jim, as you're talking about that, you know, the one thing that we really haven't said a lot of through this whole thing, there was caution in the 40s, there was caution in the 70s, caution in the 80s, caution all the way along,
Uh-huh.
because there wasn't a tremendous amount of research and development ever really done with it. It's like, well, if it's gonna freeze and you can't put in a dry valve, use this stuff, but don't use a lot of it.
Yeah.
And that was really, if you were to
Right.
read 13,
Yeah.
that's kind of what it said.
Yeah.
So Tyco, FM did some antifreeze testing, and these systems are difficult because people want to use them in places where it's difficult to install sprinklers. We had similar experience with the ESFR cold storage. But there was research, there was data behind it, we knew what we were kind of doing. Everywhere else, I would argue that there was antifreeze installed. I don't believe there was a lot of research testing, there was
to
just
support it, yeah.
not a lot of,
Right.
not a lot of,
Right.
And remember, when the 2009 fire incident in Truckee, instantly you go back through your notes and you go back through the history and you find the 2001 event that was in a restaurant with a outdoor heating element.
Outdoor seating area,
Yeah.
and it was
And
protecting that area.
Someone knocked off a sprinkler doing some maintenance and he flashed. And we had that report since
Right.
2001. But there are thousands upon thousands of antifreeze systems out there
Right.
that we never heard a word
Right.
about.
Right.
So you get that first instance in 2001, then you get the 2009, and everyone's trying to study, everyone's trying to analyze this in 2009, and the Research Foundation eventually gets involved.
Right.
But, your initial reaction as a committee member is, it can't be that broken, because we'd be hearing this
Absolutely.
Exactly.
constantly.
Right.
I was,
And every activation of an antifreeze system should blow up
Right.
the way you are hearing this.
Yeah.
And then when you start detailing 2009, and I know it was subject to litigation, so we won't
Yeah.
get into any of the concentrate levels or anything
No.
else, but you started to question as a committee member, was it mixed properly? Did it fit that
Sure.
concentrate level on some inspection? We don't
Yeah.
know, and
Was
I
it a
don't know
solution?
the answer to
Yeah.
that. Did you have more than 60 or 68% concentrate at the drop when that thing activated? And really, was it a
Right.
true antifreeze in accordance with the standard, or was it just something a little bit different? So the reaction of the committee wasn't as aggressive and panicked, because we needed more information.
Yeah. And that's where, the conventional wisdom at the time was that. And as we were moving into it, as we started the research project, and you and I were on that panel that kind of went through that, the thought was this was an anomaly, that there's almost no way we can recreate this in the laboratory. That was, and we were going into that, you know, the whole literature search
Yeah.
that was done in that phase.
'Cause we still
So,
didn't believe
so
it.
Scott and I were at UL when we
Yeah,
did
and
this.
Sean Orr, too.
And, well, was it Sean
Sean was
too?
the guy running the pump.
Oh, was
out
he?
in the- Yeah, right,
Okay.
yeah.
So we're running this, we run this test, and we run the first test, and it's 5 feet out into
Yeah.
the spray pattern, the fire, the flash fire, we started all off. Nothing, puts it out. We go out that evening, like you do,
Yeah.
Study
have a few beers.
Study flammable liquids in a
so
glass.
studying flammable liquids.
In a
have
glass.
They were
have a few
miscible,
beers.
too.
We're raising
They
a
were
pint.
miscible, black and tans,
That's
yeah.
right. We're raising a pint, saying, duh, it's an anomaly. There's no way we're gonna do this. So what do we wanna do next? Okay, let's move it in a couple of feet.
Yeah, so kind of move the ignition location as, with
A
respect to.
little
the
closer to the
Relocation.
sprinkler
Sure,
head,
yeah.
and rattled the blast-resistant doors on the test facility. That pressure wave
Yeah.
that came off of it, and it kept burning until we turned the system
Yeah,
off.
it kept-
It actually put out the fire in the pan, but
It was just, yeah.
but the sprinkler kept burning.
It
So
was-
we knew we had a problem then.
Yeah, and
The
through
discharge
through the
kept
research
Yeah, the discharge
foundation,
kept-
literature search, and,
Yeah.
you know, the initial things that were going on, you know, and you feel kind of strange as a committee member, knowing that you're putting a combustible liquid or flammable liquid
Mhm.
into a sprinkler system, but again, we just sort of lost sight of that because it was all on economics and 40 gallons.
Yeah.
And when these new fluids and new testing was coming out, they're saying it was okay, but
Mhm.
we weren't really doing the pressure spectrum, we weren't really doing all this other testing that we
Right.
do today.
Well, and I think most committee members really looked at the standard and said, they're recommended to be small, so they are small.
Mhm.
And of course, there's contractors, there's a lot of people on the committee, so there was a whole lot of people in the back going, small.
Yeah.
You know, there's, a
Uh-oh.
lot
Yeah.
of them, there's nothing small about.
Right.
And even the substantiation, you know, they voted against my
Mhm.
recommendation, which at the time, was fine, it's what the standards do. But it was based on, there's no historical data to support this change.
Mhm.
And we do a lot of that, because, well, there's not a problem, why,
Right.
why
Right.
make a
Right.
change?
Yeah.
And I don't disagree with that, it was
Mhm.
just one of those things that we were recognizing.
Yeah.
You know, people calling Viking and talking about, when literally fitters were calling, how should I enrich the antifreeze?
Yeah.
And I'm telling them to throw them away, and then a customer calls, why are you telling my guys to do that? Shouldn't you? You know?
Yeah, yeah. Well,
Yeah,
so there we stand. We stand with this, the other event that occurred shortly after this research, or after this particular project. That was June of 2010, when we were at UL. And we were thinking, okay, a reaction to a flash fire might actually do that. That might have the energy that's necessary or a grease fire. So we thought, okay, shifted a little bit, going, that was a pretty extreme situation. I wonder if it would happen with just a normal set of combustibles. Well, we didn't wait too long for that answer, unfortunately. Harriman, Utah, in June of 2010, was a simple cigarette fire in a living room with the exact scary scenario similarities.
It was a couch fire, the
Couch
cigarette
fire.
didn't set the sprinkler off.
True. The cigarette didn't. It was a couch fire. Yeah, no, it was a.
It's for the children.
Sorry, it's for the children, just saying.
There you
Just
go.
saying, all right. So, yes, that's absolutely right, it's a couch fire, but it was an ordinary combustible.
Right.
So that was then all of a sudden now, okay, so that throws that out, it's a problem all over. And then NFPA starts to take a series of really extraordinary steps, shutting this entire thing down with a safety alert that
Right.
said, basically in residential, you guys should drain these things. You should just drain them all out. Now this is where I want to get with this is where talking to you guys about kind of what the heck is the industry going to do? Because by now I'm back into the industry as an industry advocate. How the heck are we going to get to this? But then a series of TIAs. Now, James, you're you're chairman of Standards Council now, so you know what they're limited in doing, and yet kind of these extraordinary steps that they took in the process, just because this was an event that nobody saw coming. And it was, you were really cutting new ground here. So,
Yeah, for something to, get a safety alert from NFPA has to be pretty unprecedented. They don't issue a lot of safety alerts unless there's a danger to life or something that they feel is that necessary. And being a member of Standards Council now for a number of years, we generally regulate the process of what the technical committees and what's
Right.
brought before the council as work by the technical committees such as 13, 13D, 13R. But this one was happening at such a fast pace, and I wasn't on the council during the 2010,
Right.
11, and 12 period, where they issued 3 different series of TIAs in conjunction with the committee, in conjunction with the Research Foundation, because it was that important. But it was very difficult in the field to explain what was going on, because the first reaction was, don't get it out of the system.
Right.
Don't have any of this in your sprinkler system. And people just can't convert a wet system to a dry system.
right.
It doesn't work that way. And to try to put air pressure, and so it really put the AHJs at a disadvantage to the NFPA with the TIAs, because they didn't know what to do. So
Right.
they were really, hey, I've been an advocate for fire sprinklers for 35 years. I'm up in Colorado. I've installed 300 or 400 antifreeze systems because that's all they could do, and they leave their house during the winter.
Right.
And they don't turn the heat on, but they turn all the water up, but the fire sprinkler has to stay active. So they put in antifreeze. And now you're telling me I have nothing to replace it with. So many of the AHJs that I spoke to just said, I'm taking the risk that it's better than nothing. And many of them just kind of watched the process of NFPA. I'm not going to allow any new antifreeze until
Sure.
there's a listed or pre-mixed listed program out there. But, council was doing the best that they could to keep up
Sure.
with the Research Foundation and the NFPA technical committees. But pretty unprecedented that TIAs were coming out as fast as they were.
Right. Because there was additional research after we did the residential fire. There was additional research that was done. There was a second, or I can't remember the numbers, but it was next phase, where they did.
It was a few more phases.
Yeah,
it
there was at least 2.
UL took it upon. I mean,
Yeah.
it was all the calorimeter testing at UL. Measuring flammability before and after at certain flow rates of or discharges of the antifreeze of the water.
Right.
To try to create different droplet sizes, different
Yeah, K-factor
pressures.
differences.
And so there was a full matrix that was created with, orifice size, pressures, flows, concentrations, and there was a whole kind of matrix that was developed to say, okay, 50 PSI with this orifice size, and glycerin, no good, but maybe with propylene glycol, it's okay. And,
Right.
at the end of the day, I think it came out that, glycerin was good up to only, 30%, and propylene
38,
glycol was good to
40.
50%,
Yeah.
but the 30% glycerin, is only has a freeze point of like, 0 to,
Right.
1 below
It
or
wasn't-
whatever. So it wasn't practical to use
Wasn't-
anymore anyway.
Right.
Propylene glycol was still okay, but that's no good for CPVC, and so it was good for our ESFR, but cold storage, but then whatever. So they just kind of canceled themselves out after all that data was available. How can you justify letting it continue, right?
Right.
Other than the sunset clause that was granted to the existing systems.
Right.
So-
So, and that was
But there was a lot of research done on that at UL, and then, requirements were passed accordingly.
Yeah, that leads into the kind of the next edition of NFPA 13, where following the TIAs, they shut down everything. They said, you're not putting any antifreeze in new systems, and 13 could make that clean cut like that, because it was new installations. So they could say, okay, nothing unless it's listed. Well, there
Unless
wasn't
it's
anything
listed
listed.
as
The
such, right.
real challenge then became, as you just said, the existing systems and NFPA 25, and that's where there was this huge kind of Rube Goldberg approach to, I mean, it was just, it was logical, but boy, it was kind of hard to walk people through all the language You got it right there. Just because it's that hard to remember how to do.
Just happen to have it.
You just happen to have it here. But it was, all right, that's great. We can shut it off in new, but now how the heck are we gonna catch up with what's already there? What do we do with those guys?
Right, we had the magic date of September 30th, 2012, because
Yep.
that's when we said, stop, don't go forward with
Mhm.
any new systems. So we
Right.
had to deal with the legacy issue of systems installed prior to 2012.
Right.
They could have whatever capacity, because it was only a recommendation.
Mm-hmm.
And the concentrate, if you go back in time and you look at the concentrates that were allowed, there was up to 70%.
Sure.
So we had very high concentrates where the graph where you see the fluid temperature comes down, then it starts to
Then it spikes, yeah.
get worse again. But
And that was supposed to be educational.
It was like, don't do this.
Yeah, don't make it too rich.
But you just had to draw the line in the sand somewhere and say, okay, these systems exist. You can't just drain them and make them a dry system, and you
Right.
can't just add water because they're obviously subject to freezing.
Sure.
So, we always say this about the NFPA process, is that they can assume some risk in the standard.
Mhm.
And we have quite a history leading up to that point, and that's the decision that they made, that
Right.
2012 prior has to hit an A, B, and C protocol.
Right.
And if you meet A, B, and C, you can survive until September 30th, 22.
Mhm.
But at September 30th, 22, you're going to drain that system and put it with a listed antifreeze.
So okay, so now let's pivot towards the listing. I don't want to, you can spend hours dissecting the 25 language and the risk analysis and all the other stuff that came along with it. But you just closed with unless it's listed. Well, we went on for a few years before anything listed came out, and now we're moving forward. There is listed and there's a new listed. So why don't we talk a little bit about where we're at now and where we're going? What did we do?
Well,
What do we got?
We are partnered. We're really just kind of working alongside Lubrizol.
Mm-hmm.
And Lubrizol has a new fluid called freezemaster
Mhm.
that just received its UL listing. I saw it in the directory for an email that was just sent out. So it's got some unique applications. I'm sure we're going to talk about that, about what hazards it can handle, where the system volume limitations still apply, and really kind of a forward-looking thing of how are we going to apply this in NFPA 25. I think we can talk about that here.
Mm-hmm.
So, I mean,
So where are we, Scott?
yeah.
We're in Caledonia, Michigan.
Oh, okay, very good.
Well, we're currently,
Oh, okay, just saying.
Yeah.
we're currently on NFPA 13D and 13R,
Mhm.
residential occupancies, unlimited in capacity.
Mhm.
So if it's just feeding the residential area
Right.
of 13R, if it's, and limited application of, small ordinary hazard area, so
Mhm.
that'll be in the listing for freezemaster. But essentially for the residential sections of 13D and 13R, it's unlimited capacity.
Okay.
As soon as you start getting into some of the occupancy considerations, you start hitting some of the volume limitations.
Right.
For an example, light hazard occupancy, it's for less than 200 gallons, so above 40.
Mm-hmm. Still that magic 40.
Everything starts and stops at 40, so
Right.
up to 40 in light hazard
Mhm.
means nothing.
Right.
You just calculate it as a wet system.
Right.
There's
Mhm.
really no special protocol.
Mhm.
When you get above 40 to less than 200, the calculations are going to be based on the light hazard to a wet system
Mhm.
for the freezemaster fluid.
Okay.
Above 200 to 500 gallon capacity, you're going to have a limit that you have to use. You have to select your area of operating sprinklers based on them being a dry system.
Okay.
So you're going to have the 1.2 times your square root of the area,
Times 30%.
about 30%
Yeah.
for the square root
Right.
of the area. So you're
Right.
going to have more sprinklers in your
Right.
design area for the dry. Even though you'll still calculate it wet, you'll still the hydraulics will be for the Darcy-Weisbach.
Okay.
They're gonna enforce the Darcy-Weisbach for the antifreeze, for the temperature that it's at.
So the increase, real quick, so, a lot of times we have all these funny rules, so the increase is based on expecting more sprinklers to open, correct?
Yeah.
Like it
Yes.
is on
In a dry system, the penalty, yeah.
I just think that's important for people to understand.
Yeah, that-
Like there's somehow getting penalized, like, well, no, we expect a few more sprinklers to open, so
Right.
calculate them.
Yeah,
Right.
And that's really kind of, to kind of simplify it, we think it's wet. We had an 1,100 gallon limitation, of course, we were storage, but it was based on, things that we knew. We knew how it was gonna exit. And 200 gallons,
Mhm.
no problem, between, once you get above that, plan for more sprinklers to operate. So
Okay.
it explains the hydraulics a lot better in a very manageable way. I'll have more heads operate.
Yeah.
As opposed to, we don't know, or,
Right.
I think there's a little more science behind this, so I think it's worth at least, kind of highlighting that.
highlighting, sure. So, all right, so we're up to that larger,
So
that
you have
area.
the 40 gallons pretty much across the board, right?
Mhm.
In all occupancies, 40 gallons or less,
Right.
it's use a listed antifreeze. It's only when you want to go above 40 that you start hitting the limitation of 13D and 13R for unlimited. And then, let's say you were doing an attic
Mhm.
in a 13R. Now, that's always a debate. What
It's
is it?
always the
Is it
debate.
we
Sometimes
all-
not a
We all have
choice.
our cute names for it,
Yeah.
of what the code is called. But people say it's a 13 application in the attic.
Yeah.
And then a 13R down below. And that's fine, but if it's light hazard 13, then you're gonna have that 200 gallons or less. You'll calculate it as a wet system. And then 200 to 500 gallons, you're gonna calculate it as if it were a dry system.
Mhm.
And 500 gallons currently is the maximum volume capacity right now for antifreeze
Okay.
in light hazard,
Mhm.
in a light hazard application. In 13R and 13D, it's unlimited relative to the residential application.
Okay.
And then 40 gallons for other hazards.
So
That's kind of where we are.
That's where we're at right now. So we've got our freezemaster coming out soon. I've actually, as part of this series right here, I'm going to be talking with Mark Nurek from Lubrizol. He'll be a guest here, and we'll talk to him about kind of their plans for launching that. And anything else, anybody want to, anything we've missed here while we're,
One thing, just.
to wrap up?
Yeah, just one thing, when you talk about the design area for dry and going a little bit for a few more sprinklers, it's hard to compare yourself to water when you're not water.
Right.
It's
Sure.
a fundamental.
Yeah.
When you go into the lab.
Very good point.
And they're going to test you exactly to the performance of water.
Mhm.
And then they're gonna put some additive or some fluid in there that prevents freezing and compare the two. They are not going to be identical.
Mhm.
So this isn't really a significant penalty. This is just kind of addressing the issues now through research that we know more about it
Right.
than what we knew before.
Mhm.
But I would take an attic in a dry system calculation mode for area of operation over a dry system any day.
Yeah.
Trying to, get an attic with all the pitch and everything else in
Oh,
a
yeah.
four-story building, it
Sure.
isn't easy with the compressor and everything else.
Mhm.
So it still has a huge economic value to have the antifreeze in that system.
It lessens the complexity of the installation, and
Correct.
anytime we can do that, it's always best. And you look at it, when you talk about the history of testing, how much testing has occurred over the last couple of years? A lot of testing.
Yeah.
Back in 2003, we realized 50%
Yeah.
water just meant 50% water, which is no different than what James just said.
Mhm.
It's different than pure water.
Yeah.
And when you talk about 13R, and you're running a attic and the pendant sprinklers for the residential area on the same system,
Mhm.
now it's a wet system,
Right.
and you have water or fluid immediately.
Mhm.
If you do dry, if you pay attention to residential dry, you have to have water in 15 seconds.
Right.
Yeah.
Right.
So
Yeah.
what we were forcing people to do was run a wet system under the insulation,
Mhm.
and then run a dry system above for the attic. So
Right.
the cost was just compounding with the antifreeze, and with it being unlimited down below, but limited to the 500 or less for
For
the attic
attic,
area.
right.
you're gonna get the economic benefit of a combined system for that top floor.
Great.
So
Looks like we've-
there's some advantages there.
Looks like we've solved the problem. We're moving ahead now, and 2 years ahead of the deadline.
Okay, let's, just before we conclude though, let's talk about the future challenges, and that's, you know, something like a storage facility that has antifreeze in a legacy, or an ordinary hazard parking garage.
Right.
You know, that's the elephant in the room,
Yeah.
is there's a lot of parking garages with
Yeah.
antifreeze.
Yeah, yeah.
Because it was the 2 stories of parking garage and condos on top,
Condos
or
on
a,
top, right.
or a business on top. And they just ran antifreeze, and then that's great. But what is ordinary hazard anymore, and what is a parking garage? You know, I was on NFPA, these guys are still on NFPA, but I was on NFPA 13 for 20-something years. And I was trying to figure out what an electric vehicle burned like, and I was trying to understand what a car stacker was.
Oh, yeah.
And you
yeah.
put 2 cars on
Another
top
one.
of each other. You know, and we threw out extra hazard group 2, I believe, because it was the highest density we could
That we could
apply
throw
to a
on there,
car
sure.
stacker.
Yeah.
But, you know, if we go to UL and say we want ordinary hazard group 2 with antifreeze, we don't even know how water performs
Yeah,
with these
we-
new
right.
electric
With these-
vehicles.
with theirs,
We've
right.
had some very large fires, and there's challenges. It's not that antifreeze can't do it, it's we haven't defined completely what this ordinary hazard challenge
What it is.
is moving
Right.
forward.
Even with
Right.
water, right?
And I
Yeah.
think,
It's
and
a tough part with the baseline on that.
Yeah,
Some
there
of
is
the
no
stuff-
baseline.
Yeah,
That's
that's what I
the
mean. There's no
long way of saying it,
baseline
there's
for
no
it.
baseline.
Yeah.
right, and
So
I
how
think
can
the
you go to
committee,
antifreeze?
I believe the committee just moved parking garages to group 2 for a proposal for the 2022
Yeah.
edition?
And there was,
Is that
yeah, and
accurate?
Yeah.
and
I'd
plenty
heard
of
that.
discussion.
And again, that's like a flip of a coin to say, well, it must be bigger than 1.
Right. Because we've had a
Let's-
couple of really bad
let's-
ones, and that
let's
looks,
go
it looks
to-
worse than 1.
Because I was looking for the data, I was looking for the fire test, because I'd love to see the fire test, then I'd know what to test antifreeze against.
Right.
But I haven't seen the
Right.
data of burning a Tesla yet.
No.
Anyone that wants to
Well,
volunteer.
and
Right.
the tough part about that, you know, especially with parking garages today, when you look at the data on parking garages, a lot of the fires in parking garages are in unprotected spaces. So there's all this kind of funny things that are being reported. When we talk about the electric cars and some of the big fires, they were definitely in unprotected spaces. So the baseline, there is no baseline.
There's no
as far as
baseline,
I'm
right?
concerned.
That's, yeah.
And we know it's bad.
Mm-hmm.
We know it's bad. Cars today, gasoline car is much safer than they were in the 70s. And we all remember, you know, it being in cars 5 wide in the back with no seatbelts, but it was
Sure.
all steel, remember? And they
Yeah.
were safe.
Yeah.
And today we've got bladders and
Plastic
and
and
fuel
bladders.
tanks. We have things where people go, oh, the gas tank's plastic. It's like, it's a fully designed, engineered fuel cell now. It's not like it was in the past where, when's the last time somebody had a rusty gas tank? In the 70s, that was a pretty
Big.
standard
It's just-
operating
yeah,
thing,
that's
you
it.
know?
You got rid of the car.
So that's a tough part with a baseline on parking garages, and the committee just knew, we don't, you know, and I sit on the discharge committee, and there was a lot of discussion, there was a lot of people that were kind of quiet through it, because the last thing you wanted to do during our new COVID NFPA committees were just say me too.
Yeah.
There are a lot of very valid points. Everybody was pretty comfortable knowing it wasn't really group 1.
Mm-hmm.
Maybe it was never supposed to be group 1,
Right.
but it seemed like it was okay. Just because the activity in a parking garage didn't seem hazardous, you were parking.
Yeah.
Now we're entering something else into the equation where the fuel cells are different.
Right. Fuel cells are different, car stackers make it different, now you got shielded fires, you're introducing a whole bunch of things in there that we really don't know. And unless we have a sprinklered facility that has a fire in it, where we're applying water to one of these things, we really don't.
And that's what makes it difficult to test against it, to prove that this particular antifreeze can be used in higher hazard occupancies.
Yeah.
So we gotta define what that is.
Right.
Right.
Yeah, absolutely.
So that's the future, we still got work ahead.
There are a lot of things. I mean, you look at, there's some storage facilities, small storage facilities, because now they're going to what I would call almost micro storage, to where they want to be able to deliver in an hour, which means they have more storage facilities. They're just not quite as large. And in the past, and near any airport, there were all these dry storage areas, and it was just stuff coming in and
Yeah,
out.
distribution
Right.
centers, yeah.
Yeah, well, they drop it and they go, they drop it and they go. So it never was distributed. It was like the truck was there, or maybe it was unloaded for a week or so.
Yeah.
And things are just changing quite a bit. We're looking at micro storage and automated storage. You look
Sure.
at just weird things like that, you know, we're going to catch up to. Unfortunately, you know, it's like, you
Yeah.
can't legislate fast enough. You know?
But the partnership with Lubrizol, goes back to our Blazemaster partnership. So we extrude pipe and fittings under the Blazemaster trademark
Yep.
as a partnership with Lubrizol. So working with them with the antifreeze was sort of a natural fit because of our sprinkler expertise and their expertise on the chemical properties of the antifreeze.
Right.
Made for a great partnership going through. It's their listing. We have a couple of special applications to Viking sprinklers that go with it that are in our attic technology. So that'll be in our attic data sheets. But beyond that, it was really a positive experience working with them.
Great, great. Well, thanks, guys. This was a lot easier than I thought it was going to be, getting all you guys in the same room with me.
We had to go widescreen though.
Yeah, we had to go. You're going to need to use your widescreen, kids, on your computer to get us all in.
We didn't think it could contain us.
All right, so thanks guys again. This has been Jim Lake, Scott Franson, James Golinveaux, Martin Workman for Viking Tech Talks.
I get a last name now.
You got it right, yeah.
You get a last name. Not like Cher.